Well, students, today's topic is about nuclear fusion. This is the 8th topic of chapter 18, and nuclear fusion is the reverse phenomena of nuclear fission. Last time we read about nuclear fission, in which a heavy nuclei splits up into two lighter nuclei. The phenomena of splitting up of a heavier nuclei like uranium-235 into two lighter nuclei like barium and krypton is known as fission, and this releases a vast amount of energy. Today we are going to talk about nuclear fusion. Fusion means कि दो lighter nuclei आपस में fuse हो जाते हैं, जुड़ जाते हैं. Now let us see the definition of this. When two light nuclei, जब दो हल्के nuclei like hydrogen, deuterium, tritium, when two light nuclei combine to form a heavier nucleus, the process is called nuclear fusion. So nuclear fusion is the process in which two lighter nuclei fuse together to form a heavier nuclei. In nuclear fission, a heavier nuclei splits up, breaks up into two lighter nuclei. So in this fusion process, the equation, the nuclear equation is like this. You see hydrogen plus hydrogen, this is hydrogen, one proton and one neutron, which is deuterium, plus tritium, one proton plus two neutrons, deuterium plus tritium combined to form a helium nucleus, plus one neutron is released along with energy. Pictorially you can represent that this is a proton, this is a neutron. So deuterium atom combines with tritium atoms, one proton, two neutrons, to fuse together to form a helium nucleus, two protons and two neutrons. Now this is actually, it's the intermediate nucleus which happens for a very short time, a fraction of a second, and then helium is formed. This further breaks up into helium and a neutron is released along with energy. So this is the pictorial: hydrogen, deuterium plus hydrogen, tritium, deuterium plus tritium, they combine together and an intermediate nucleus is formed, just like we talked about this in fission, and this remains for a fraction of a second. The life of this intermediate nucleus is for a fraction of a second and splits up into helium and a neutron released along with energy. Now let us explain this phenomena. The mass of the final nucleus is always less than the mass of the original nucleus. Why? Because energy, mass gets converted into energy according to the mass energy equation of E is equal to mc square. Now if an atom of deuterium is fused with an atom of tritium, then a helium nucleus or alpha particle is formed. The energy released from the sun and stars is supposed to be the result of fusion of hydrogen nuclei. All this energy that comes to us from the sun is the energy which is the result of fusion of deuterium and tritium hydrogen isotopes. And helium is formed along with energy which is released in the form of sunlight or heat that comes to us. The temperature in the center of the sun is approximately 20 million Kelvin. The temperature in the center is about 20 million Kelvin, which makes fusions favorable. You know, fusion reaction can take place when the temperature is very high. and when temperature is high, then the deuterium gets fused with tritium. This fusion reaction cannot occur unless there is high temperature present. Now, according to the reaction, 4 hydrogen nuclei fuse together to form a helium nuclei, and along with the release of 25.7 million electron volts. Along with this is the release of about this much amount of energy. And mind it, this happens when deuterium and tritium, they get fused together. It is because of that, and this happens in every atom, so a vast amount of energy is released. Remember, the amount of energy released in a fission reaction was about 200 million electron volts, and in a fusion reaction is 25.7 million electron volts. The definition of electron volt was given to you yesterday. Now let us talk about the hazards of radiation and safety measures. Now, what are, as you have read yesterday, that the uses of this radiation is found in medicine, where we use radioisotopes to treat cancer. It is found in agriculture to find out about the absorption of the phosphates that plants absorb it. Then it is used in industry to find the wear and tear. And this radiation, though it is useful, can also cause considerable damage. And today we are going to talk about the hazards of radiation and what safety measures can be taken for it. Radioactive materials are widely used in nuclear power plants. The nuclear power plants also use radioactive materials. And like the one we have in Karachi, the Kanoop, it uses this as this fuel. Nuclear power plant of Karachi uses this material as its fuel. Then in the Chashma, nuclear powered submarines also use these radioactive materials, and intercontinental ballistic missiles also use. What are the hazards of this radiation? It can cause burns, and this is mainly due to the beta rays and gamma rays. It can cause redness of the skin, and it can cause burns on the skin. Skin ko jala deti hai radiation. Sterility, ये ज़्यादा absorption of nuclear radiations इंसान को जो है नामर्द बना देती है, because वो बच्चे पैदा नहीं कर सकता फिर. It sterilises the human metabolism, the human systems also. Then it causes, the radiations causes genetic mutations, and these are normally found in humans, in human beings and plants. And serious deformities occur. जब बच्चा पैदा होता है तो उसकी टांगें टेढ़ी हो सकती हैं, उसकी 2 के बजाय 3 टांगें हो सकती हैं, because it causes genetic mutation. इसी तरह से plants में भी जो है ये genetic mutations पैदा कर देता है. These radiations cause leukemia also, which is blood cancer. It can cause blindness, अंधा भी कर सकता है, और कैटरैक्ट भी पैदा कर सकता है आँखों के अंदर, जिसको मोतिया कहते हैं. And you remember a famous disaster happened in 1988 in Chernobyl disaster, when the Chernobyl nuclear power plant got busted. It melted away some meters of concrete, and then it escaped. The radiation escaped into atmosphere and caused immense damage, both billions of dollars in plants and animals. So what are the safety precautions for this nuclear radiation? We must handle these sources, the radioactive materials. The materials must be handled with forceps or tongs. हाथों से ना इसको पकड़ना चाहिए nuclear material को, radioactive material को, बल्कि इसको चिमटे के साथ या forceps के साथ पकड़ना चाहिए. Similarly, हाथों पे gloves पहनने चाहिए उसको पकड़ने से पहले, और अपने हाथों को बाद में धोना चाहिए. We must wear rubber gloves and wash our hands afterwards. And third is, we must store radioactive material in lead. Radioactive material को हमेशा जो है ना lead के boxes में store करना चाहिए, जो है ताकि वो उसके radiation absorb कर ले. Store radioactive sources in lead boxes and never point a radioactive source towards a person. कोई radioactive source को कभी किसी शख्स के नज़दीक उसको रुख नहीं करना चाहिए, उसको पॉइंट नहीं करना चाहिए ताकि उसको रेडिएशन अटैक ना कर सकें। एंड इसी तरीके से जो सेंसिटिव एरिया है जहाँ पर रेडियो एक्टिविटी हो रही होती है, जैसे न्यूक्लियर पावर प्लांट्स में या फिर न्यूक्लियर पावर सबमरीन में, उस एरिया के नज़दीक ज़्यादा फ्रीक्वेंटली नहीं जाना चाहिए, उसको अवॉइड करना चाहिए ताकि आपको रेडिएशन का एक्सपोजर जो है वो ज़्यादा ना हो सके। सो नाउ आई गो ओवर द मेन पॉइंट्स। Yesterday we talked about nuclear fission. The fission is the phenomena, is the process in which a heavier nuclei, splits up into two lighter nuclei. And today's topic is about nuclear fusion. In nuclear fusion, in two lighter nuclei combine to form a heavier nuclei. What is nuclear fusion? फ्यूज यानी फ्यूजन मैंने क्या दो लाइटर न्यूक्लियाई का आपस में जुड़ जाना। When two light nuclei combine to form a heavier nuclei, this process is called nuclear fusion. And nuclear equation इसकी जब बनती है ड्यूट्रियम प्लस ट्राइटियम, यानी एक इसमें ड्यूट्रियम में एक प्रोटॉन होता है, एक न्यूट्रॉन, और ट्राइटियम में एक प्रोटॉन और दो न्यूट्रॉन्स, ये कंबाइन होते हैं, हीलियम बनता है, हीलियम एटम विच इज He, दो प्रोटॉन्स और चार, इसके अंदर टोटल मास नंबर है, plus one neutron is released along with energy. Pictorially, a deuterium atom and a tritium, combine to form an intermediate nucleus, and then helium is formed along with neutron and release of energy. The mass of the products is always less than the mass of the original nuclei, and this loss of mass is actually gets converted into energy. And if an atom of deuterium is fused with an atom of tritium, then a helium nuclei or alpha particle is formed. The energy released from the sun and star is supposed to be the end result of fusion of hydrogen nuclei into helium nuclei with the release of energy. The temperature in the center of the sun is approximately 20 million. So this kind of temperature is very favorable for the hydrogen, deuterium and tritium nuclei to get fused. फ्यूजन रिएक्शन जब भी होता है इसके लिए हाई टेम्परेचर चाहिए होता है। हाई टेम्परेचर की वजह से ये जो है ना लाइटर न्यूक्लियाई फ्यूज हो जाते हैं। So this temperature is available in the sun, therefore this reaction of fusion takes place over there. And according to the equation, according to this reaction, about 4 hydronuclei combine to form a helium nucleus along with release of 25.7 million electron volts. Okay, and the hazards of what are the hazards of nuclear radiations? Radiations are useful in medicine, agriculture and industry. हमने इसके मुतालिक कल बात की थी. We talked about it that radiations are useful in medicine, they are useful in agriculture and industry. लेकिन ये नुकसानदेह भी होती हैं radiations. What it can cause damage. And this is what we are also trying to find out, how to be careful about it. Radioactive materials are widely used in nuclear power plants. They are also used in nuclear submarine and intercontinental ballistic missiles. The hazards are they can cause burns and they can cause redness of the skin. और ये redness of the skin और जो burns हो जाती हैं रेडिएशन की वजह से मोस्टली ये बीटा पार्टिकल्स और गैमा पार्टिकल्स से होती हैं. It can also cause sterility, which means the inability to produce children. It can cause genetic mutations in human beings and plants, and it can cause leukemia, which is blood cancer. It can cause blindness of the eyes and can form cataracts in the eyes. And we remember a famous nuclear disaster in which Chernobyl nuclear reactor got bursted. It just burst and melted away and released a lot of radiation which affected the plants and animals. The safety precautions of the nuclear radiations are: please handle the sources with tongs or forceps, always wear rubber gloves, and store radioactive material in lead boxes, and never point a radioactive material towards a person, and please avoid sensitive areas where nuclear radiations are being formed, and don't frequently visit that. Okay. With this we come to the end of it, and the end of this chapter. I hope you'll go over it. You'll talk to me on my WhatsApp number if you have any difficulties. Thank you.